Welcome back, physicists. Today we're going to take a look at standard MAT.C1. I can draw accurate graphs, recognize graphical relationships, and solve for the slope and y-intercept of linear graphs. So first, let's talk about the graphs themselves. So remember that from your experiences in your math class, where you usually have y and x on the horizontal and vertical axis, right? In physics, it's not always going to be y versus x. As you've seen so far, right, we might have position versus time. We could have velocity versus time. Like, there's no end to the possibilities. So it's really important that we think about horizontal and vertical when it comes to these axes directions. Remember, every graph has to be labels, right, with the appropriate units, right? No labels, your graph doesn't mean anything. And we've already talked about the different types of graphical relationships, including linear relationships. We talked about quadratic relationships, and we'll see some more relationships as we go. But the thing I really want to focus on in this video is thinking about the slope and the y-intercept of linear graphs. So let's start with a concrete example. Okay. So here, let's make this a x versus t graph, x measured in meters and t measured in seconds. Okay, and I'm going to add a graph here. So let's add some points. Okay, and let me add some units, some labels as well. So 0, 3, and 1, 2, 3, 4. Okay. The first thing that and then I'll also go in and let me just kind of fill in what this graph would look like. So the first thing that we can calculate or do to a graph is we can look at reading a point. Okay. So I can come over and I can say, oh, I like this point on the graph. What is the coordinates of that point? Okay, and for this, I'd get an ordered pair that at 2 seconds, the graph is at 3 meters. And depending on what I want to know, maybe I need the 2 number, maybe I need the 3 number. But the first strategy is just reading off a point. The next thing that we can do to our graph, okay, is to calculate the slope. Okay, we know that calculating the slope is rise over run, which we will think of for this graph as a change in x, delta x, divided by a change in time, delta t. Remember, the change of would be the second x minus the first x divided by the second t minus the first t. So to calculate the slope, we need to pick 2 points. So let's pick a second point. Okay, so now my 2 points we have got at 1 second, 2 meters, and our original first point, that at 2 seconds, we are at 3 meters. So the change in the x, we go from 2 to 3, so that's plus 1 meters, divided by the change in time, which is plus 1 second. So we have a slope of 1 meter per second. And it's really important that we think about the units as well, not just the number there. Something that we can tell from the slope is whether or not that x, that vertical variable, right, is increasing or decreasing. So we know that a positive slope, which is what we have here, tells us that we are increasing. Okay. In addition, how do we get the units of the graph? Well, the units of the slope, we see that the vertical unit tells us the top number or the top unit in our unit of the slope, and the horizontal tells us the denominator. Okay. Being able to calculate the slope lets us do things like write down the equation of this line. So to write down the equation of the line here, generally a line y equals mx plus b, right? So we have to replace the 4 variables that we see here. So how would we do that? Well, we get the y in y equals mx plus b from the vertical axis. We get the x variable, or the independent variable, from the horizontal axis. We get the slope from completing this calculation, okay? And we would get the y-intercept, b, by reading off a point off of the graph, specifically when time equals, or the horizontal axis equals 0. So for this graph specifically, we'd say x as a function of time is equal to 1 meter per second times time plus 1 meter. Again, we got the x from the vertical axis. We got the t from the horizontal axis. We got the y-intercept by reading off the y-intercept, the vertical intercept on the graph, and we got the slope by completing a calculation. Okay. The last little skill connected to a graph that I want to talk about is what's called 3, calculating the area. Okay, so let's actually grab this graph. Okay, and let's bring it on over. Wait, hold on. Okay, so here's our graph from earlier. Let me clear out some of this stuff. And now let's say I want to find the area underneath this graph. That's what I'm trying to do. So the first thing I want to do is I need to pick the 2 points that I want to measure the area between. So let's say we're going to do that between 0 and, let's say, 2 seconds. Okay. Now, the area is everything that is inside between the curve or the graph and the x-axis. So we are trying to find this area here. Now, I don't know this shape. I don't have some formula that will tell me what the area of this shape is, but I can cut it at this point here, and I can figure out the area of this triangle. I can figure out the area of this rectangle, and then I could add them together. So let's start by looking at the triangle. Okay. To find its area, I know I need to do 1/2 base times height. So what is the base and the height of this triangle? Well, the base goes from 0 to 2 seconds, and the height goes from 1 to 3. So it is 2 meters. Okay. So I'll do 1/2 times 2 meters times 2 seconds, and I get 2 meters times seconds as that area. For the rectangle, I see that its base is still the 2 seconds. Its height goes from 0 to 1, so it is 1 meters tall. And I know that the area would just be length times width, or base times height, however you want to think of it. And so I'd get 1 meter times 1 second equals 1 meter times a second. And so the total area by adding would be 2 plus 1, so 3 meters times seconds would be the area. Now, for this specific example, the area isn't really communicating something to us. We'll talk more about what it can tell us when we're analyzing kinematic graphs. But notice how now the units of the area are equal to the units of the vertical axis times the units of the horizontal axis. Meanwhile, back in calculating the slope, they were divided. And that's really, really important to us. And so that is how we can draw accurate graphs, recognize our graphical relationships, solve for our linear relationships by calculating the slope and writing an equation for that line. It's something that we'll be using throughout the unit and throughout the year. Thanks for watching.